Hey everybody, Bill Sky, the C++ guy. And what we're going to start talking about today is object-oriented programming. We're going to compare it with something you should already know, which is an abstract data type called a structure, how those two work together, and how to actually use it to benefit you in your programming. So let's get started. Now I have an Eclipse C++ project opened up here. And the first thing I want to talk about is just a little bit of a review, and that is of structures. What is a structure? Well, remember in your first semester C++ class, if you took one, a structure is an abstract data type. So let's say if we want to create, and if you remember, we did this in the dynamic puppies video that I did prior to this. We created a structure called puppy, and we gave that structure different data within it. Like for instance, we said the name of the puppy. We used chars because chars are a really easy way of structuring a file if you're going to be writing out puppies to a file. So we're going to say name, we're going to say breed. You can do things like age in years. And you can do things like weight in pounds. So this is what we call an abstract data type. It is a new data type that you created using in language data types, like a char, an int, a float. You could even use a string. The problem with a string, though, is that a string can be any size, so saving a puppy to a file might become a problem if you use strings. But it is a collection of data types that are native to the C++ and the C language, all put together in a new data type, in this case called a puppy. So that's just a little bit of a review of what an abstract data type is. Well, object-oriented programming takes that one step further. Object-oriented programming takes that abstract data type structure puppy, and you can actually create what they call a class, which is a blueprint, which is much like a structure. It is a blueprint for an object, in this case puppy. So what we can do is I'm going to create a class. Now, I created a structure here called puppy. I'm going to call this puppy struct, just so we can differentiate between the two. And what I can do inside of my main is I can create a class called puppy, and within that, and notice that the integrated development environment Eclipse, it handled it just like a structure, because a class is a structure. And a class is a structure, though, with many more capabilities. And this object-oriented programming is really put together to make coding easier on you as the programmer, and to give you more flexibility and more structure in your code. Object-oriented programming also gives you the ability to assign functions called methods to your class, to your puppy in this case, that is only associated with that puppy, to manipulate the data within the class. So you should really never do it this way. You should never create a class inside of your main. So let me show you the right way to do it, and then we'll actually put together the class called puppy. And the way that you would do this, and Eclipse is really great with this, I'm going to right click on my project right here, and I'm going to select new class. And Eclipse brings up this little window that says, what should the class name be? Well, I'm going to call it puppy. And down here in the header, I always like to put PP. Now, the three of the companies, of the many companies that I've worked for, IBM, AT&T, and I believe it was Martin Marietta in Florida, whenever you wrote a C++ program, your header files would always be HPP. If you wrote a C program, your header files would be .h. So that differentiates those two header files. You might think of them as include files. But what's going to happen when you create this class is that the definition of the abstract data type is going to be stored in the HPP file, but the implementation of the functions that are associated with that abstract data type, in this case called puppy, are going to be implemented in the CPP file. It is very rare that you put the actual program code in the HPP. You always put the program code in the CPP. Now, there are situations where you might need to do that, like virtual classes and things like that, but or templates, I should say. But in this case, we're just going to put the implementation, the actual logic, in the CPP, and we're going to put the abstract definition in the HPP. And that's really all you need. You just put in the class name there, you change the .h to .hpp, and then you click Finish. And Eclipse does everything for you. So you'll see right here that we have a class called Puppy, and we have this other thing called Public. That means everybody can see what's underneath Puppy, or underneath Public, I should say. And what does that mean? It means your main program can see it. It means anybody that uses Puppy can see it. So that's what Public is all about. If you want to make things private to Puppy, you would use the private keyword. And then anything inside of there would be private to Puppy. But we're not going to do that just yet. We're going to leave it just as public. Now, what do you do at this point? Well, just like with a structure, if we go back to our main, just like with a structure, you specify the data inside of the HPP file. And I'm just going to copy and paste that. So I'm going to put that right here. And so you can see that we already have some commonality between a structure and a class. Instead of structure, or instead of struct, you say class. But then there's some additional stuff, like I already showed you public, I showed you private. There's also a thing called protected. There's things that are specific only to the object-oriented programming class data type, or abstract data type definition. Now there's a couple other things that you see here. These are function prototypes. So you've got a thing called Puppy. So if you have a function that has the exact same name and as the class, this is called a constructor. If you have a function with the exact same name as the class, but with a little tilde, that's that little curly character, which should be to the left of your number 1 key on your keyboard, that is called a destructor. But those are functions. Now, I can also create my own function. I'm going to create a function which is going to return nothing, called print my name. It's going to take no arguments, and that is a prototype of a public function that I just created inside of Puppy that's going to print my name. Now notice there's no code there, it's just the prototypes, because that's really what the HPP file is used for. It's used for prototyping your data. Now I'm going to copy this function prototype, so just right click on it and say copy. I'm going to go to the puppy.cpp file, and I'm going to implement the code. Now, one thing to remember, when you put the function prototype in your CPP file, you must precede it with the class name and 2 colons. So now print my name in the CPP file is associated with the Puppy HPP, or the Puppy class. I'm going to get rid of the semicolon at the end, and now I can actually implement my code. So I'm going to say, and let me go ahead and save and build this. Okay, so I'm going to say tout this dot, and I'm going to say name. Now this is a keyword that we use in object-oriented programming, which means me, the current puppy that's being processed, and I'll show you that in just a little while. Now there's some other things that happen here, because Puppy CPP is really independent of my main CPP file. So Puppy CPP doesn't know anything about cout or count. So what we need to do is we need to pound include iostream, and we need to say using namespace std. And we can do that inside of my Puppy CPP file, and it compiles fine. Now, do you normally put it in there? No, you really don't. You normally will put it in the HPP file for Puppy. And the reason that you do that is because the Puppy CPP file includes the Puppy HPP file at the top, so it'll also include the #include IO stream and then using namespace std. So that's normally the way it does it. So you could also think of the HPP file as the supporting file. What does my CPP file need to actually execute or compile correctly and then execute when we run it? So there's our very first class called puppy. Now you can also see here that the constructor, remember the constructor has the same name as the class without the little tilde, and we actually don't do anything here, which is fine. And then we've got the destructor, which has the little tilde in front of the class name in the actual destructor function name. So those don't do anything right now. Notice how Eclipse says to do. You've got to do something in there. There's something to be done in there. If you wonder what that's all about, I can go down here to tasks and you can see that I've got to-dos. So that's a way in Eclipse to remind yourself that you need to do something. So we'll get to that when we start talking about more advanced. Now, how do we actually use my puppy class? So what I'm going to do is right here, I'm going to say #include puppy.hpp. Put a little space there. And so now my main program has complete access to the puppy class. It's really neat how this works. And so now I'm going to go down here and I'm going to create a variable called puppy, and I'm going to call this variable myFirstPuppy. Now that's a static variable. It is not a pointer, but it is a static variable. I'm going to create another one called mySecondPuppy. So I can make as many of these as I want. So let's look at this for just a moment. This is a class called puppy, which is a template for an object. So a class is like a structure. It doesn't actually create the variable. It just defines what the variable will look like when you create the variable. However, when you go into your main and you actually create a variable called myFirstPuppy, what it does is it goes to the puppy.hpp file and says, oh, myFirstPuppy is going to have all this information in it. So I'm going to create an object, or I'm going to create a variable called myFirstPuppy that has all that data in it. Just like a structure. It's exactly like a structure, but with additional stuff. Same thing with mySecondPuppy. Okay, so let me go and I'm going to put some data into myFirstPuppy. So I'm going to say myFirstPuppy, and we use this syntax dot, that punctuation dot, and I can specify a variable. Now because this is a C string, I have to use the strcpy. Now we haven't included everything that we actually need here for the strcpy to work, so I'm going to come up here and I'm going to say #include C string. So now it should compile. So what I just did here is I said copy the word Cassie, the name Cassie, copy that C string into the myFirstPuppy.name. So we actually put the data into that object's name attribute. They call it an attribute or a variable. Object-oriented programming, they call the variables inside of a class attributes. This is the same as a variable inside the class. And I'm going to do the same thing here, mySecondPuppy dot, and this is one of the nice things about Eclipse. It shows you all of the attributes inside of the class for puppy. So I'm going to say name. All right, so we're setting data here. Now let's continue putting data into Cassie. So myFirstPuppy dot, and I'm going to say breed, and that's going to be a Cocker Spaniel. Now, of course, this has to be strcpy. There we go. And now I'm just going to copy this and change myFirstPuppy to mySecondPuppy. And this is going to be a Jack Russell Terrier. My spelling is off today. All right, good. And I said my second puppy. Let's make it second puppy. Okay. So let's build that. All right, awesome. Now we put some data into those puppies. Let's print the data from the puppy. So I'm going to say count myFirstPuppy.name, cout my second puppy dot name. Now you don't have to wait for the list of attributes to come up. You can just hand type them. All right. I'm going to save and build it, and I'm going to run it. And you can see we did the hello world, which is up here. We did the program ending, which is down here. And we put the data Cassie and Cocker Spaniel, Jack and Jack Russell Terrier, and we're printing the name attribute for my first and my second puppy. Now I can expand this. And I just love this feature of Eclipse. And let's run it now. And we can see that we've enhanced it. We have now, it says Cassie is a Cocker Spaniel, Jack is a Jack Russell Terrier. So you can access those attributes anytime you want. And why? Because they are public. Everything underneath public means I can access it. Now in a future video, we're going to talk about the difference between public and private, but for right now, that's what we've got. Now, one thing that we haven't done is we haven't used this print my name yet. So in my main, instead of me accessing the name directly by doing the cout or the cout, I'm going to say my first puppy dot, I'm going to say print name. What this allows you to do is it allows puppy to be independent of your main, and puppy will decide how to print the name. Now in this case, this actually won't work. If I try to save and build this, it won't actually work because print name, what does print name do? It actually sends something to the cout. It doesn't actually return anything. So instead of that, what I could do is I could say char asterisk. It's going to return char asterisk puppy get name, and then it will return the name. But we're going to talk about that later when we talk about functions that return data. But so for right now, we're just going to leave it where we're going to access the data directly from the class. Okay, now one other thing I want to talk about is the constructor and destructor. So if you remember in your HPP file, you've got a constructor, and how do you know that? Again, it's because the name of the function, the name of the method, in object-oriented programming, they talk about functions inside of a class. They call them methods. But inside of the class called puppy, it has a function called puppy. That's the constructor. Another function that has the name puppy but has the little tilde, that's called the destructor. Now the constructor is executed when the class or when an object of that class is actually created. And what does that mean? When I actually create my variable right here, my first puppy, it's going to execute the constructor. And the same thing right here, my second puppy, it's going to execute the constructor. So we can kind of do some neat things here. I'm going to say, cout, you're creating a puppy. So we can actually see that executing when we run our program. So I'm going to run it, and here you go. So it says you're creating a puppy. That's this line of code right here. What actually happened, it went into the puppy CPP file. It ran automatically. It ran the constructor, which couted you're creating a puppy. Now it didn't print the puppy's name because we haven't set the puppy's name yet in our main. So it didn't do that. Then when we created that variable, it went ahead and printed this because it executed the constructor inside of puppy. So constructors are something that occur when you create the variable. Now what about the destructors? Well, the destructors happen when the variable is destroyed by the program automatically or by you by issuing a delete statement if you allocated it dynamically. So I'm just going to say cout, you're deleting, and I'm going to use the name because we set the name, this dot name. So when the puppy is deleted, when it's removed from the program's memory, the destructor will actually be executed. Let's see how that works. Let's build it. Let's run it. And here you go. So we created 2 puppies. That's this code right here. We did our hello world. We set the values of Cassie and Jack, first puppy and second puppy. We printed the data, which you can see right here from within that class. Now, it's kind of weird because it says program ending, have a nice day, and you can see it printed there, but then it says you're deleting Jack and Cassie. That's because those variables are automatically deleted by the C++ runtime, by the operating system, when the program ends. So when the program ends, it will automatically delete any static puppies. So that's why you see them there. Now, there's one other thing you can do, which I think is totally a lot of fun. What I'm going to do is I'm going to put a breakpoint right here on line 29. And the way I did that was I moved my mouse over this little blue vertical bar to the left of line 29 and double clicked it. And now I'm going to click the debug. And we can actually see this happening. So I'm going to switch to the debug perspective. And you can see the little arrow right there. That means that we're debugging at that line. And I'm going to step over, step over, step over, step over. Now we're copying the data. So this is a little review. We're outputting it, outputting it, outputting it, outputting. Program ends. And you can see how when the program ended, it printed those because it ran it in the destructor. But let me show you something else that's really cool about this. I'm going to turn off the breakpoint on line 29. I'm going to put it on line 24. And I'm going to debug this program. Okay, so I'm on line 24 right now. Watch what happens instead of step over. Watch what happens when I press step into. And I'm going to press step over. Oh, something happened. Program died. So let me go back. Let me close all this up. Now, what I wanted to show you was how it went into the constructor. So what I'm going to do is I'm going to go into the CPP. The debugger is kind of messed up here a little bit. I'm not sure why. I'm going to go into here and I'm going to put a breakpoint on the cout of the constructor and a breakpoint on the cout of the destructor. Go back in here and debug it. Okay, I'm going to step over. Step over. Ah, look what happened. When I created the variable my first puppy, it automatically took me into the puppy constructor and it's showing the output. So I'm going to press step over. I'm going to press step over again. Went back in for the second puppy and executed the constructor. Now I'm going to go ahead and just do my normal stuff here. End the program. And look what happened. It took me into the puppy destructor because that puppy is being deleted from memory by the C++ runtime system. Again, another puppy is being deleted because that's my second puppy that I created. And now the program is done. So there's our introduction to object-oriented programming in C++. We're going to have many more of these on object-oriented programming because there's so many interesting features of that in C++, and I hope to see you at our next video.